One of the driving factors in product design right now at SunLink is this convergence between energy and technology. We're bringing a distributed tracker to market because we see an opportunity to optimize these projects. The thing that was most important for us was to convey this message that SunLink is looking across different industries and bringing that into solar. So TechTrack for us means so much more than the best-in-class mechanical and structural solution. For us, TechTrack is a partnering of technology and tracker solutions in order to really bring to market a product that solves the entire energy need in solar projects. So people are looking to SunLink for guidance in how they make their purchasing decisions. EPCs are beginning to ask us our perspective on distributed versus centralized trackers because of the unique position we're in, where we have O&M services available, we have installation services available all through PowerCare, and then we also have Vertex coming out that gives us so much data into what is actually happening in these systems. Tracker design is an interesting thing because there are these two competing schools of thought where you have distributed trackers and centralized trackers. We have different projects and different project locations and different project needs that need either a centralized or a distributed technology. A centralized system tends to work better in large flat sites. A distributed system tends to work better in challenging terrain, irregularly shaped project boundaries. A centralized tracker tends to work better when O&M maintenance is a concern, if a project is very remote, or if there aren't people and kind of the technology in place near to that project site that you could easily do O&M. A centralized tracker is more reliable. A distributed tracker can be the better solution if you are in a location that has more availability to services and isn't so remote, because you can really fine-tune performance on a row-by-row basis. So you have these pros and cons that it shouldn't be a one over the other in all cases. It should be that we're looking at each of them and deciding which project should go which way, or should a project be a combination of both, with different locations on the project site needing one solution, other locations needing the other. Where I think that there is potential for innovation on Tracker is really more on how we use the intelligence of the system, the data of how the system is performing, and we say, what can we do to teach our system to act better? And then at the same time, we're monitoring energy production. So we can constantly be weighing pros and cons of responding to different environments. So do you move out of the way of the wind? And then what's the effect on energy production when you do that? So then we can fine tune how often do we move out of the way of the wind? What do we allow our system to do in terms of its ability to move in 5-degree increments, 10-degree increments? How far away from optimal do we allow it to move as it's getting away from wind events? And as we do that, we not only optimize the system in real time that is already installed, and we can use this for protecting our legacy systems, protecting systems out in the field that they'll never experience or never have structural failure because we know what they're doing and we know that they're moving out of the way in these critical wind events. But it also helps us design products for the future. So right now, O&M companies are taking projects and seeing that they're a tracker and just applying a blanket quote to that project. That isn't going to continue indefinitely, because within the next year, 2 years, 3 years, we're going to have a lot of data on these systems. And with that, we're going to be much more empowered to make real decisions on what does a system cost when it's installed, what does a system cost when it's being maintained, and it'll help overall understand better LCOE on these solar investments.